Hello my dear students, my name is Akash Dubey and today I am here to discuss about all MCQs of solid state chapter from class 12th, and this particular MCQs are from Maharashtra State board textbooks. So before I start with the session, so my dear students, please subscribe and like this video. The session is going to be interesting, so please make sure that you all are watching this complete video to understand each and every concept. And also I have made videos on numerical, and if you need videos in English or any different languages, means Hindi, especially I can't talk Marathi well, so you can let me know in comment section. Definitely I will try, but from now onwards I'm trying to make some videos in English as well. Now let's start with the topic and let's understand few MCQs from the solid state chapter. So let's see the first one. So what does it say? It says molecular solids are. So basically if I say you if I ask you about one molecular solid example, you know so can you give me that example? Yes, ice is one example of molecular solid. So when we had discussed regarding the solids, so we had discussed about two things. So we had discussed the solids can be classified into two categories. The first one is crystalline and the second one is amorphous, and this molecular solids comes under the category of amorphous solid. So B is going to be your correct answer. Now let's move ahead and let's discuss the second one. So what does it say? It says which of the following is n-type semiconductor. So when we had discussed about semiconductor, if you will watch my videos about solid state, so that whatever I have discussed in that particular playlist is up to board level only, not for the J and NEET level. So if you're preparing for board exam, then only you can watch that video, otherwise you can skip. Definitely you should set your bar very high, so you should watch the videos of J level, and definitely I will make videos of J level as well, and very soon I will upload all the videos. So when we had discussed, let's come to the discussion. So when we had discussed about the semiconductor, so in that case we had discussed two things. The first one we had discussed about n-type, and the second one we discussed about p-type. So you can remember n is nothing but negative, right? And p is nothing but positive. So you can remember using these words. Negative means electron, positive means lack of electron. It means that holes would be there, right? Means holes would be there. Now let's come to the discussion. Now if I have this silicon and if I will dope this silicon with group 3 element. Group 3 element means what? Group 3 means nothing but Bal Ganesha in Thailand, right? So basically if I will dope them with group 3 elements, so in that case what is going to happen? In that case there will be lack of electron and the holes will be generated, and we are going to get p-type semiconductor. So from here itself you can see gallium and indium, they both are from group 3, right? But if I discuss about arsenic, so nitrogen, phosphorus, arsenic, so these all comes under group 5. So basically what happens in case of group 5? So here if I have, let's say if I have arsenic over here, so the valency of arsenic is going to be 5, and it is going to have one extra electron, and this extra electron will be responsible for conduction of electricity. So this is the reason why we are saying this is n-type semiconductor. But in case of p-type semiconductor, the scenario is very different. And here we have, let's say, boron. So in case of boron, you know what happened? In case of boron, there is lack of electrons. So because of this, holes are generated. If holes are generated, so in that case, what happens? The electricity conduction is by means of these holes. So I hope you have understood regarding n-type and p-type semiconductors, and their working as well. I explained you. So here the correct answer is going to be your silicon doped with arsenic, because here pure silica is just a semiconductor, but this is not n-type and this is not p-type semiconductors, and C and D, both of these options are incorrect. Now let's move ahead and let's the next one. So in Frankel defect, so what happens in case of Frankel defect, my dear friends? In case of Frankel defect, you know what happens? Basically here what happens? If I try to explain you, so let's imagine here we have many atoms, if I have many atoms present at these particular sites, and let's say these are positive negative like this. So what happens over here? So if any ion leaves its site and it occupies the interstitial site, so this is your interstitial site and it is leaving from its own position and it is coming over here. If it will come over here, so this will become vacant. So this position is vacant now, and now this particular ion is present over here. I'm marking it with red color so that you can understand it. So here now, the one ion, let's say any cation or anion, whatever that is present at this site. But what you can observe that no ion has left this particular system. So no ion has left this particular system means what? There is no change in mass. So there is what? There is no change in mass. And also, if there is no change in mass, so you can assume that there is no change in density as well. So density also doesn't get affected. And what next? What next? The next one is, anion and cation both are not leaving this system. So basically they all are also present, and the total number of positive and negative charge are same. Positive and negative charge are same. If positive and negative charge are equal, so what is going to happen? In this case, we can see that overall electrical neutrality is maintained. So your correct option is going to be your D, where it says overall electrical neutrality is preserved. So your option A, B, C, these all are incorrect. Now let's move ahead, my dear students. Let's see this one. So what does it say? In crystal lattice formed by BCC unit cell, the void volume is. So please remember, please be careful. They are asking about void volume. They are not asking about APF, atomic packing fraction, right? So in case of BCC, we all know that in case of BCC, 68% of the volume is already occupied. So just imagine if I have this, if this is the unit cell. So in this case, what happens? 68% of the area is occupied, and how much area will be left? So 32% will be left. Simple calculation is that, because overall it is going to be 100%. If 68% is occupied, so we can remove 68 from it and we will get 32% only. So 32% area is void. What is void? Void is nothing but this is empty space. So this is empty space. I hope this is clear to you. Now let's move ahead. So C is going to be your correct answer. They are asking the coordination number of atoms in BCC crystal lattice is. So now how do we find coordination number? So basically if I discuss coordination number of any atom, so it means that that atom is in touch with how many more atoms. If suppose if this particular atom is in contact with four more atoms, so in this case the coordination number will be 4. Now let's discuss about crystal lattice of BCC. So in case of BCC, it looks something like this. Now we all know that one atom is present at the center. Let's say this is, I have painted it with red color. Now let's see the next part, and in this case what you can see, in this case you can see that four atoms are present at the top corners and four atoms are present at the bottom corners, and this red color atom which you can see over here, this is in contact with all these 8 atoms. So 1 2 3 4, and this is also in touch with these 4 atoms which are present at the bottom. So total 8 atoms are there. So the total, basically what is happening over here, this red color atom is in direct touch with 8 more atoms. So it means that the coordination number is going to be 8 over here. So here the correct answer is going to be D. Comment down what is the coordination number in case of FCC. Comment down and let me know in chat section. Now let's move ahead and let's discuss the next one. So what it is saying, which of the following is not correct? So they are asking about incorrect statement. So before I read these all statements which are written over here, let me tell you that if number of atom is n, let's say the total number of effective atom is capital N, then tetrahedral void is equal to 2 into N, and octahedral void is basically this will be equal to the number of effective atoms. So if you will read this option C, so what does it say? It says if the number of atom is N, then the number of octahedral void is 2N. But you know what it must be? It must be N. So we can say this statement is wrong, and hence C should be your correct answer, because they are asking about incorrect statement. I hope this is clear to you. Now let's discuss the next question. What does it say? A compound forms HCP structure. Number of octahedral and tetrahedral voids in 0.5 mole of substance is respectively. So you can just calculate. We all know that one mole of any substance has 6.022 into 10 raised to 23 atoms or molecules. But here we are basically dealing with uh, you know number of atoms. So let's keep that one only. So here we have been given 0.5 mole. So here total number of atoms you can imagine is, so this would be half of this. So here I am writing 3.011 into 10 raised to 23. And how did I get it? So I have basically multiplied by 0.5 or 1 by 2 into 6.022 into 10 raised to 23, and you will get this as your answer. Now what I told you, if number of atom is equal to n, then octahedral void will be equal to n. So here total number of atom is how much? This is 3.011 into 10 raised to 23. So octahedral void should be what? It should also be 3.011 into 10 raised to 23. So first of all we need to write octahedral void. So that is the reason you can see in option 1 3.011 is there, so we can mark it as correct one. B, C, D will be cancelled. Now if I discuss about tetrahedral void, so it should be how much? It should be 2 into n. If I will multiply this particular value with 2, then 2 and 2 will get cancelled, and again I will get 6.022 into 10 raised to 23. So practically our option A is correct one. Now let's move ahead and let's discuss the last question of this particular chapter. So what does it say? It says lead has FCC structure with edge length of unit cell 495 picometer, radius of lead atom is. So what are the data given to us? So they are saying this is FCC, and they have given us edge length, means the value of A is given to us, that is nothing but 495 pm, and they are asking about the value of R. Now what is the formula? The formula is 4R is equal to A into under root 2. So we just need to put all the values into this particular equation and we will get our answer. So R will be equal to A is nothing but 495, because all the options are given in picometer. So we will move ahead with this given value. So this is 495 multiplied by 1.414 divided by 4. So if you will multiply it, because if you will multiply it and you will do calculations and all, so you will get your correct answer as 175. Don't try to do approximation over here, because the values are very close to each other, like 175, 185 and 205. So these three values are close to each other. So if you will do approximation, so you might get 185, so that will lead to incorrect you know answer. So that is the reason, when in the option, when the values are in approximate to each other, then you should try exact calculation, you should not ignore it. So that's all for today, my dear students, and thank you so much for listening, and take care. Bye bye, see you again. And to uh, type a message in the comment section and let me know you want the videos of which topic again. So that's all for today, and take care. Bye bye, see you again. Have a nice day ahead.